Okay, we are live. Make sure that everything else is live here. Guys, let me know if everything is working okay on your end. Looks like it is. I always go through this because I'm always paranoid that the stream isn't working. Oh, okay, there it is. All right, and I hope we were trying to fix the audio issue that came up with the YouTube video this morning. It looks like it got corrected, but if not, let me know. So it sounds like it's good there. Okay, so a lot to talk about. Last week I was off, and we were celebrating our anniversary, having a good time and eating tons of candy. So that was fun. And we had launched the winter forecast. And so what I wanted to do this evening is kind of go over some of that, see where we are in terms of the observations since that launch, and also take your questions, of course. We also have a storm that we're going to be keeping an eye on. The model guidance has generally shifted east, which is great news, but I still am a little bit concerned. So we're going to have to keep an eye on that. Okay. Well, good. All right. I'm trying to learn. The funny thing about doing all this stuff, and I actually went to school for this. It called the Connecticut School of Broadcasting. While I was trying to figure out what I wanted to do with my career, and I went in to learn all this audio stuff and everything. But it still takes time to learn because I'm a scientist, not a, Anyway. So we have a lot to talk about while I'm rambling, and yes, I do have coffee. And oh, by the way, we have launched the merchandise. We have started to launch it, and we are still adding. We wanted to start off with something basic with the t-shirts, and in fact, I should probably pull up the website here just so you guys know where to find it. And the reason why I started creating this stuff, or Susan started creating this stuff, was mostly because, quite frankly, it was requested. So I'm like, oh, okay, sounds good to me. So this is on the landing page of the website. If you go scroll down here below the content about public forecast, premium consulting, business consulting, then you get the merchandise. You go click on here. And then there's the latest merchandise that is available. We got our hoodie, and I've ordered every one of these, so I'm testing them out so that way, the quality is good and everything. But I ordered a hoodie because I need a new hoodie anyway. So, and we're going to be getting black shirts and white shirts and all sorts of shirts and women's t-shirts, all that good stuff. So that is something good. We're also looking. I'm trying to find a brand of coffee to do with the weather. Right now I have French vanilla, but if there's someone who's producing coffee and you do a sponsorship, I think that'd be really cool and kind of apropos for, well, basically what I do, right? Which is do a lot of forecasting and drink a ton of coffee. I think I single-handedly support the coffee production in South America with the amount of coffee I drink. So there you have it. So I wanted to touch on, first of all, our storm threat. And take a look at the water vapor satellite picture. This is some really, really interesting stuff here. What's happening here with this shortwave in the subtropical jet stream. Why is it interesting? Because we're going to learn a couple of factors in terms of the interaction between the polar and subtropical jet streams. Now, in this case, we don't have a true high latitude blocking regime. We're kind of in between blocking regimes in the setup involved here because we're moving out of a favorable storm environment with below normal temperatures towards a milder weather pattern. And so when that happens, you get a strong jet streak driving into the west coast. So the timing of that jet streak can either push a storm off the coast and lead into more of a fish storm, if anything, or it can be delayed a little bit and you end up with one last powerful storm before the pattern transitions into a mild pattern. But what I am interested in is the degree in which these shortwaves in the subtropical jet stream can become enhanced. And the reason why I am very, very interested in that is because of what I'm seeing with La Nina. Now, let me pull up this right here. Now, this is the latest La Nina charts. Right? We can all agree that we have La Nina. It's generally an east-based La Nina. And you can go to tropicaltidbits.com and you can look at each one of the charts here of where we are in the daily values. So Nino 4, which is basically towards the date line, right around here, that's around minus 0.489. That's not very cold, to be honest with you. It's about cold neutral. Then you go to 3.4, much colder, minus 0.987. Nino 3, 0.7. And then Nino 1 plus 2 is minus 1.05. Now, the reason why I find this very interesting is because I think, as I discussed in some premium discussions this week, that we are seeing the peak of this La Nina. And the reason why I say that is because of what I'm seeing in the subsurface, which, let me pull that up real fast. And I should have pulled this up beforehand, so I apologize, but for some reason it didn't load. But, this is perfect. Okay, so the subsurface temperatures have reached the coolest point, and they're starting to moderate now. And that's a really, really important signal. You see, if your colder water below these cold anomalies is already starting to moderate, that means we're starting to move towards a change, okay? So I think that we've seen a peak in La Nina. And it's generally weak and basically east-based. And that drives our convection, which we'll enlarge that. Now here's our date line. And where do we see most of the convection? To the west of the date line. Why is that important? Well, Cosin and Ussolini strongly suggested in their book, Northeast Snowstorms. If you don't have it, definitely get it. It's an amazing book. It's 2 large books. You can get it from the AMS. Wonderful holiday gift, by the way. Hanukkah, Christmas, whatever. When you have convection around the date line and to the west, you're more likely to see East Coast cyclogenesis or storms on the East Coast. That doesn't necessarily mean snowstorm. It can mean a rainstorm very easily. It just kind of depends on the air masses you're dealing with here. But the point is that you're not going to be having a raging southeast ridge. Instead, what you get is a ridge, around the Bahamas. So, what did we say in the winter forecast? That the ridge is going to be displaced more towards the Bahamas and maybe the Florida coast. And you're going to see a trough axis somewhere around the Mississippi River Valley and a storm track from the Tennessee River Valley jumping to the mid-Atlantic coast. This is a signal of that potential. So that's a very interesting signal showing up. Another interesting signal showing up is the snow growth in Siberia. Wanted to touch on this real fast. Pretty much it's on the low end of the average of the past 5 years, but still above average overall over the past 20-year, the 30-year average, should I say. So it's still above normal, but not strongly so. We're still seeing a relatively weak polar vortex element here. And you can see that really nicely here in the latest guidance on the European. And you can look at the GFS too. You're seeing a disruption, a stretching of the polar vortex already. And you can see that also on the GFS, if it loads. Decide not to load tonight. Oh, that works. Oh, there it is. You see that evolution right here. So what does this tell us? Well, the polar vortex overall, the more that it's disrupted in the winter, the more likely you're going to see high latitude blocking showing up. And that's why we're starting to see these signals showing up here, especially for the long range guidance of these periods of below normal high latitude blocking, and then we go back to above normal and then below normal again with the Arctic Oscillation, EPO, constantly negative, NAO, negative, positive, and turning back towards negative. So what does this tell us? Well, this is a typical La Nina signal where you get transient air masses, transient blocking regimes. So nothing really locks in place. It's very, very rare in a La Nina winter to get sustained high latitude blocking, sustained cold weather patterns, unless you're in the northern plains. We're usually in that battle zone. But I would say that when we are in these phases of a negative NAO and negative Arctic Oscillation, that is when we're going to see our best potential for some pretty good winter storm potential. So as far as what I'm looking for in terms of La Nina and the weather pattern overall and the winter weather pattern, I'm liking what I'm seeing with the observations. And I'm liking where the pattern is going overall. And I'm also liking what I'm seeing with the angular momentum, where we're seeing more sustained negative values showing up as we head towards December. Why is this important? A negative AAM supports more development of these upper level lows and upper level troughs getting cut off and more high latitude blocking. So again, all these signals are all coming in together. Now that takes us to our storm. And here is the factor I was talking about. This is 300 millibar winds. Now you see this feature right here? This is a little bit stronger on the 12Z guidance than it was the 0Z guidance. A little bit more aggressive. And the reason why this is important is because it kicks this storm out further east. If this is a little bit slower, which is certainly possible, because you're seeing this break here, you see how this kind of cuts in. So if this jet streak is a little bit weaker, that allows this storm to track closer to the coast. If it's as strong as what's being advertised this afternoon, and that's pretty freaking strong, then that's going to kick this storm straight out. It's typical of these type of transient weather patterns that we typically see around this time period. And so you can see on the 500 millibar PVA, you see how that misses? It just misses. And so you end up with more of a positively tilted trough. However, the 0Z guidance from this morning, it allowed that capture. Why did it allow that capture? Because this jet streak wasn't kicking this out too fast. So I think that we're going to nail down exactly what to expect for this weekend. Which again, if there's anything that's going to be focused, it's going to be on Sunday. We're going to know it by tomorrow morning. Because by then we'll have enough data where we're in that 90-hour range where I could trust where that jet streak is lining up and just how much of a room I have for this storm to interact and come up the coast, or get kicked out into the Atlantic without enough time to do that phase. And see, it all comes down to the speed of this disturbance right here. In the new guidance, it moves in such a way that it doesn't have time to dig. And so as a result, it ends up with a weaker storm, basically just scattered cloud cover on Sunday. And then we move into our mild pattern briefly with a Pacific air mass marching on its way through. But notice, even in this pattern, where you have basically unfavorable conditions for any type of significant cold air intrusion, you're still getting these upper level lows getting cut off here, which is, again, a very, very impressive signal because that increases the potential for, again, high latitude blocking. So there's a lot going on here in this pattern, and there's a lot to work through. And let me take a look at let me pull up the ensemble guidance here for 500 millibars. Let's take a look at the 12Z. Let's see what happens beyond 10 hours. So here we are at 10 hours. Look at this. We already see our trough returning to Aleutians, our ridge building over the west, trough over the east, and it basically locks in very nicely towards the end of November. This is a very important signal again, because it leads to a feedback. This feedback allows for transport from the troposphere, where we live, up to the stratosphere, up to towards the higher latitudes, and this signal is what starts to telegraph a disruption of the polar vortex. So kind of like a feedback pattern again and again on itself. The old high latitude blocking instigates the support for new high latitude blocking. So as the atmosphere is trying to balance itself. So this signal, while I would never take any of the specific details seriously, the overall theme is what I like. Okay, the overall theme is what's catching my eye here. And the overall theme is a constant return of a ridge in the west, trough in the east, and building heights towards Greenland, building heights towards the Arctic, and an upper level low somewhere around the Aleutians. When you get that combination, then you really have to be on your toes for active weather. And while I think this might be a little too fast in the evolution, I do think that towards Thanksgiving, we'll likely see a stormy period. That's essentially what I like to see here. So now with that, I am going to take some of your questions, and we'll go from there. Okay, YouTube audio looks good. That's good. Coffee's good. Let's see here. Okay, so first question of the night. If La Nina has already peaked and steadily declines, will that have an impact on the latter part of winter, i.e. not as much influence, thus making it more possible for wintry weather around mid-February? I was kind of baked in the idea of a weakening La Nina already, so my thoughts on that really haven't changed all that much. One of the factors that will determine whether or not late February and March, let's say February 15th through March 15th, remains an active wintry month period of weather, would be if we see another disruption of the polar vortex that drives high latitude blocking. I think at that point, the La Nina factor would be mute anyway. You might see more of an active subtropical jet stream, but really a lot of that will come down to whether or not we see a disruption in the polar vortex or not. If we see it, then yeah. If we don't, then early spring. Let's see. Rob asks, I know climatologically, I'm doing good tonight. December 5th and beyond is usually the start of potential to see boundary layer cool enough at the coast. Do you think there is potential for frozen precipitation at the coast before then, based on what you are seeing? I really, really do not like going for a snow potential before December 5th because of the ocean temperatures. And let me actually pull that up here. let's see here. We'll do, well, maybe Western Atlantic. Okay. That is some warm water. In fact, let me pull up the Northern Atlantic. Maybe that shows up better. Okay. So that's some warm water. Really, really, really warm water. Well above normal. And that's a factor. Anytime you get a storm out here, it's kind of a double-edged sword for you snow lovers out there. Because on one hand, this type of warm water with a polar air mass coming in, let alone Arctic air mass, is going to lead to rapid cyclogenesis because of the very strong thermal gradient involved here. So a lot of rising air, a lot of support, plenty of moisture to work with. The negative side of that is that any type of easterly wind is going to rapidly warm up the boundary layer. So you're going to quickly jump from 32 to 38 with any type of easterly wind. So you need a north-northeasterly wind in early December to support the type of snowfall, especially if you have anything above an inch. So I would lean against that potential. But if you get everything lined up just right and you get like a nice little clipper dropping in from Ohio, redeveloping off the Delmarva coast, yeah, you got a shot. I can't 100% rule it out. I just wouldn't bank on it. Let's see here. It seems the interior getting freeze warnings while urban corridors get only frost. Is a great example of urban heat island effect. Oh, absolutely. Absolutely. Typically, it's hard to get a hard freeze this early in the urban areas. It's really, really unusual. I mean, even just climatology by itself, it's hard to get it on the coastal plain itself. You could definitely get it in the Pine Barrens. That's easy to do. Interior portions of Long Island. Let's see here. Connecticut, Hudson River Valley, all those areas. But usually the Delaware River Valley is very difficult to pull off this early because of the Delaware River. And of course, the immediate coast itself, unless you get nearly perfect conditions. So basically, the football forecast is up in the air. Yeah, basically. I think we'll know by tomorrow morning for sure. It's definitely trending towards a drier forecast, but drier and slightly warmer. So instead of the 40s, might be more like in the mid 50s, but definitely improving in that respect. When's it going to warm up to normal temperatures? Temperatures are below normal this week. Okay, Paul. Basically, we're looking at that by the time we get to Monday. We should be near to slightly above normal, but overall. Okay, Peter asks, negative AO, NAO, positive PNA, La Nina, convection, way west of the date line, negative PDO equals, well, let's see here. It can equal a very active winter weather pattern. It also, pull it up, in that type of pattern, sometimes what happens is that the polar jet stream and the subtropical jet stream are a little out of sync. So what it leads to is a lot of storms that, let's say, cut up the coast or cut up towards, from the Tennessee River Valley towards the Delmarva Peninsula with rain and a warm air mass, and then the cold air comes in behind it after the storm exits. And then the next storm comes and that misses. So sometimes it leads to a very active winter weather pattern, and sometimes the short waves are just a little bit off, and you can end up with some unfortunate misses, or fortunate, depending on your view on snow. I would say that that pattern configuration is better to have it than not if you're a snow lover. I'll put it that way. It definitely is supportive of an active winter weather pattern. Any early thoughts for Christmas? Not yet. I think that's a little bit too early. It's several weeks out. I'm guessing you mean whether or not we'll have a white Christmas. Again, the overall average is under 10% to have a white Christmas. So that you're already climatologically in a negative position. If you're looking for that, your best bet is actually head up towards the Poconos and Catskills. Not just because of the mountains, but also because the Great Lakes are well above normal this year in terms of temperatures. And the reason why that's important is that we're going to be dealing with when we have those polar and Arctic air masses coming in, they're going to produce quite a bit of lake effect snow. And I think that we're going to see some pretty strong bands coming off those lakes and making a little surprise visit in northeastern Pennsylvania, Catskills, northwestern New Jersey. So I think from Thanksgiving to Christmas, I think that's going to be a theme that we're going to be keeping an eye on. Maybe a couple of surprise snow squalls even reaching Philadelphia and New York City. Let's see here. Rob says, for the person who asks about Christmas, I will say hearing Steve talk about timing and water vapor telling a totally different story than the malls reminds me so much of the Boxer Day blizzard. Yes, indeed. The Boxer Day blizzard taught us a very important lesson. And if you guys are new and you might not remember that storm, about 24 hours out, actually more like 36 hours out, all the models were saying there is no storm, nothing's going to happen, go about, enjoy your holiday. And I looked at the water vapor satellite picture and I put out a post which even my parents, my dad was reading, is like, no one's calling for a storm, right? Are you sure about this? This could really hurt your credibility. I'm like, Dad, something is not right here. So I posted it, let people know. And, well, it was a heck of a storm, that is for sure. In 1 second, I'll be right back. Give me 2 seconds. Yeah, I think you're right. Well, that was fun. Sinuses are fun. Yay. Okay, where was I? Okay, right. Boxer Day blizzard. Boxing Day. Boxer, Rocky Balboa, whatever. It should be. That'd be a great idea. Play Rocky Marathon after Christmas. Makes sense. But that storm was very interesting in that when you looked at the water vapor satellite picture, you could see the interaction of the short waves, but the models, because of an error with collecting model data, with collecting observations from the balloons, specifically over northern plains in Canada, caused the models to miss the timing of the northern shortwave and the subtropical shortwave. And I'm looking at the water vapor, I'm like, something is not right here. And that's why you don't just go with models. Look at the observations. When I look at the observations here, the story comes down to one question. How fast does the jet stream come into the west coast to kick this and this shortwave out here far enough off the coast to produce a non-storm event? Simple as that. That's the forecast question. But in the meantime, I gotta say, I am very, very interested in the fact that we continue to see these upper level lows and upper level troughs around Canada, which, by the way, this is a signal here for the return of a clipper type pattern once again as we head towards this winter. There's been a lot of talk how the Alberta clipper has been pretty much extinct over the past couple of years. Well, this is the type of pattern that would bring it right back to life. So, something just to consider. Won't that also moderate air masses as they come to our area? Oh, you mean the Great Lakes. Okay. Um, Typically, they don't have that much. All right, let me put it this way. If you have a very strong Arctic air mass coming through the Great Lakes, it does pick up moisture, and the evolution of the snow band is more of a mesoscale or even microscale beta type of influence, but it won't moderate the entire air mass. It's a very limited moderation. So basically, if you're having teens and 20s for highs coming in from Western New York, it's going to reach the East Coast. It's going to reach New York City with generally about the same potential. So it really doesn't have too much of a significant moderation. What caused the very negative Arctic oscillation and negative North Atlantic oscillation around 2010? That was a combination of first it led off with very strong warm air being very warm air being transported from the tropics into the Arctic. And you know what, let me pull up, let me see if I can find it. Let me see what I look for. Here we are. This should do it. Okay, so let me open up this image. Okay, guys, this is at 10 millibars. Now you see this warming that we're seeing here? This is the first disruption of our polar vortex, in which knocked us down to cool temperatures. In 2010, basically what you had was extremely warm temperatures dominate 10 millibars and completely obliterated, and like basically it destroyed the polar vortex. If you want to have a good demonstration of this, take some hard candy, get a hammer, and smash the hard candy. Have it fly all over the place, right? That's essentially what happened with the polar vortex in 2010. And that influence, which we're starting to see here, very interesting to see this evolution take place. It caused a feedback. And that feedback led to a deeper and deeper North Atlantic oscillation and Arctic oscillation, which is basically high latitude blocking regimes. Now, understand what is a North Atlantic oscillation and a Arctic oscillation. Here's the basics, right? When you have a negative Arctic oscillation, your heights at 500 millibars are above normal. So basically oranges and reds up here. And the mid latitudes, which is where we are, has a lot of below normal or blue features. So this is an example of a negative-ish Arctic oscillation. It's not textbook, but it's getting there. Okay? So when you have a positive Arctic oscillation, all this is basically a strong upper level low over northern Canada, and basically a zonal pattern or a large ridge over the United States. So basically what that does is that the polar vortex becomes so strong that it traps all the cold air up here. So when someone says it's a positive Arctic oscillation, what that basically means is that all the cold air is up visiting Santa Claus. It's not getting down to our neck of the woods anytime soon. A North Atlantic oscillation is when you have a negative North Atlantic oscillation when this ridge builds into Greenland. And you get a strong upper level low around 50 north, 50 west. And that leads to the pattern slowing down, so that way you get a trough right around here and storm development out here. When you have a positive North Atlantic oscillation, you get this type of feature, an upper level low over Greenland, which displaces the ridge and allows storms to exit out into the Atlantic without any concern. So that's the differences between these terms. And to go back to 2010, what happened was the initial warming in the stratosphere basically nuked the polar vortex, and then the high latitude blocking that developed out of that produced a feedback pattern which made it stronger and stronger. It fed back on itself until it finally collapsed in February. Right, exactly, Peter. The collapse eventually led to a very positive, basically almost no high latitude blocking in the spring. So Card is asking, so if you could use one tool to base forecasts on, it would be the water vapor satellite. Oh man, that's tough. You can't really use one tool. The water vapor certainly would help. It would certainly allow me to see where a storm would develop. It wouldn't give me a good idea on precipitation type, or potential, how heavy the precipitation could be. There's a lot of things that I would need still, but certainly the water vapor satellite would definitely be one of my tools. Okay, so I'm being asked a question here on YouTube. Might as well check it out here. So you expect a snowy winter for eastern Great Lamis? I don't know. Okay. The winter forecast was issued. Definitely go check that out. I think this winter, as I explained 2 weeks ago, is going to be very active and very volatile. We're going to see large swings in temperatures. Whether your neck of the woods is going to have above normal snowfall is going to depend strongly on where you are in location. The closer you are to the coast, I think the more likely you're going to see mixing events. But one of the reasons why I'm very hesitant these days to say, oh, well, we're definitely going to have above normal snowfall or below normal snowfall is because with the influence of precipitable water values being enhanced in a lot of these storms, honestly, you get one blockbuster storm and you're pushing yourself to above normal snowfall. In this type of pattern, especially if you get enough isotropic lifting, you could definitely feature that. So I'd say, as I said 2 weeks ago, active weather pattern for sure. We're going to have to be on our toes. With both the Arctic, Cardiac's in our question, with both the Arctic Oscillation and North Atlantic Oscillation, orientation matters a lot, doesn't it? Somewhat, yeah. Orientation matters in a wide variety of factors when it comes to forecasting. The orientation of the troughs, whether you have positive orientation, negative orientation, speed. If you have an east-based North Atlantic Oscillation, that leads to less potential for storms as opposed to a west-based. Arctic Oscillation is pretty much standard. There's really no east or west-based feature to it. But the orientation of the troughs, speed of the troughs, there's a lot of factors that deal with that, definitely. But what also caused the monster tornado outbreak clash in 2011? Off the top of my head, I believe it was because we had run very strong polar air mass into plains and you had warm air returning. 2011 was a very active year, very, very robust year. And you also had a returning subtropical jet stream, which also would enhance that tornado outbreak. But there was no one cause. It was a multiple of different factors. And when it comes to tornado outbreaks, you really don't want strong high latitude blocking. You want a progressive pattern with a lot of short waves and a lot of jet streaks moving quickly through to support a lot of the mesoscale cyclogenesis. You don't want a sustained high latitude blocking regime because then you don't allow for a constant interaction between the polar air masses and the tropical air masses. In other words, you want progressive cold fronts in the plains to support an active severe weather outbreak. Low solar activity, correct? I mean, it wasn't that low. 2011. Let me see here. No, actually, 2011 was a very active. They only had 2 days in 2011 that had a blank sun. So certainly a heck of a lot more active than this year. It was a very active year. Less than 1% of the days had no activity, had a blank solar activity. By the way, we continue to remain active with the sun right now. About 2 to 4 sunspots a day, and some pretty strong CMEs impacting the Earth as well. So definitely an active sun is in place right now. Let's see here. So far we are doing really good. It's already 8:40. I'm going over again. Great question, guys. As always, very impressive stuff. See if there's anything going on with our radar here. Generally quiet out there. Just a few isolated showers off towards the Great Lakes. That right here is, you could thank lake effect. This is a strong signal right here. Another one right here. Now, what I'm going to be watching out for towards this winter is whether or not we're going to see any strong bands come right out from here, cut across, and drop in towards basically the Poconos and Catskills. Very interesting stuff. Let's see. Did the warm Gulf of Mexico and Gulf Stream had to do with someone who's really... Peter, you are very interested with the 2011 season for tornadoes. Did the warm Gulf of Mexico and Gulf Stream... Gulf Stream would have nothing to do with the tornado outbreak. Gulf of Mexico, well, yeah, I mean, the Gulf of Mexico is always warm. It wasn't anything substantially, anything that stood out. The really strong CME about a week ago ended up missing the Earth for the most part, just clipping the summer hemisphere. For the most part, it still caused some factors, especially with satellites. If you guys are having any problems with your satellite TVs, you can thank the sun for that. In fact, I think that a lot of cable and internet sources are going to have some issues this winter with a lot of these CMEs. I think that we're going to see more of them. I think the sun hasn't peaked yet in that activity. I would not be surprised if we get a couple of strong ones hitting the Earth, which, well, don't be surprised if your cell phones start dropping and stuff like that. It's going to be interesting. Was it last year or 2 years ago where we got a snow squall warning in New York City Metro from lake effect or a frontal passage? It was a frontal passage. Well, the front initially was enhanced by the Great Lakes where it picked up the moisture. And then there was still lingering moisture around here. And the frontal band moved through in support with a strong shortwave that basically, think of it like this: afternoon thunderstorms, but just with snow. That's essentially what we had. And it started 2 years ago. They started issuing. I don't think we had one last year, but we had 2 years ago when they were just starting to issue it. And boy, was that an impressive little snow band. Dropped, I think, a quick inch of snow, if I remember correctly. It was a pretty impressive one. Okay, so for those around the Great Lakes, especially the eastern Great Lakes, and some of you maybe around Oswego, New York, let's say, I think it's going to be a very, very snowy season up around the eastern Great Lakes with the lake effect snow. Now, whether your household itself actually gets the heaviest snow, I mean, I'd bet more in the Tokyo Plateau than anywhere else. But I think this is going to be a very, very impressive year. I think it's going to be a factor for Thanksgiving travel around the eastern Great Lakes. I really do. We got really near miss from an asteroid November 1st. Yep, we did, but it missed us. I'll tell you, I'm not worried about asteroids because it won't happen until I win the lottery. When I win the lottery, that's when we're going to get hit by an asteroid. So until then, I'm not really worried about it. I note that winter 2010-11 started with cold, stormy, ended up warm and dry in February before the 2011 tornado clash. Yes, that would make sense. You had changing pattern, changing wavelength, all of that. The winter itself was not a factor in causing that tornado outbreak. They're kind of two separate. I know a lot of weather enthusiasts tend to do this. They try to find correlation with events, but don't look at the causation or the forcing mechanisms. For example, I was having a debate with someone who was talking about our Antarctic ice and how that would influence the PDO and so on and so forth in the northern hemisphere. And what this person did was pull up graphs and say, well, look, the graphs are the same. So I asked him, what is the physical parameter? What is the driver in all of this? And basically no answer. And the reason why there's no answer is that you can always generate via statistics a sign of correlation. Like, hey, the New York Mets had 10 strikeouts today, and at the same time I got an ice cream sundae. So clearly, whenever there's 10 strikeouts from the Mets, I'm going to get ice cream. That's not there's no actual physical connection. It's just that you had two statistics happening at the same time. And that's why statistics, if you don't understand the driving mechanisms, can be very dangerous because you can misread things. So now we take that into atmospheric science. When it comes to atmospheric science, statistics are important, but understanding the underlying forcing mechanisms in the atmosphere that would support those statistics is far more important. Saying that we have a negative NAO does not mean you're going to get a storm. Saying that because there's convection around the date line, which is amplifying the polar jet stream, which is setting up high latitude blocking, that would support a storm on the East Coast. Because you see, you identified the forcing mechanisms of the pattern. So when people look at things like, warm October equals cold winter, or if the North Atlantic Oscillation is positive for most of October, that means it's going to be negative in the winter, or vice versa. Understand that. Don't worry about the statistics. Ask the important question. Well, what caused that? And why does it translate to down the road to other weather patterns, whether it's different seasons or whatnot? When you do that, then you have a better understanding of atmospheric science and the pattern overall. And then that is when you could start looking at patterns and looking at things like satellite pictures and whatnot to make a forecast. You see, atmospheric science is nothing more than studying how the atmosphere comes back into balance. Every storm, every weather event that we have is nothing more than a practice of the atmosphere trying to find a way to get back into balance. It's never achieved, but it constantly is happening. So if you understand those parameters, then you can better create a forecast and understand what's happening and understand what's happening with the statistics. As always, outstanding questions this evening, guys. I'd be remiss if I didn't take a minute to congratulate the Atlanta Braves on their win of the World Series. Of course, I have been reminded all day on social media from various news sources on baseball that the Mets until July were in first place, and then they collapsed, and the Braves were below 500, and now they won the World Series. Oh joy! Oh well. So what caused the change in 2010 and 2011? The change was simply okay. High latitude blocking does not last forever, Peter. Eventually, there has to be a collapse, and when it collapsed, that's what caused the pattern which caused the tornado outbreak. Again, what caused it was simply the atmosphere trying to come back into balance. Simple as that. It's really far more simple than any other signal or any type of driving mechanism. It simply was the atmosphere shifting from a highly amplified pattern to one that wasn't anymore. And so as a result, that's how you got your outbreak. And when it comes to mesoscale environments like tornadoes, typically what happens is that you create mesoscale boundaries that feed back on itself. You'll see this in the summer in the northern mid-Atlantic, where you'll get a couple of cold fronts with thunderstorms intensifying over a specific area, let's say over northern New Jersey, and then that echo continues on through the rest of the summer, and you constantly get intensifying thunderstorms over, let's say, northeastern New Jersey, right? And it's caused by a microscale or a mesoscale moisture gradient, which enhances other boundaries and outflow boundaries and of the more of the rest. So that also becomes a factor as well. Just a quick look at Earth New School 250 milliwatt jet. It's coming straight from Siberia across the Arctic into North America. It's very impressive. Let's pull that up, shall we? Okay. Make sure we got HD on here. Oh, there it is. Almost there. Here it is. It comes wrapping across, drops right in. Now, this type of signal here is what's going to support our below normal temperatures for this week. Something else that's interesting. Look how strong this subtropical jet stream is. Very not La Nina-like. Interesting. Better than the cheating Astros. Yeah, I can understand that. I just want the look. I am going to put it out publicly. I am available for the Mets president of operations, baseball operations. Since no one wants the job, I will gladly take it. Okay? And I could do it all from home. So, just want to put that out there. Because it seems like no one else wants it. I'll definitely take the job.
And more positive news, you got a new Godzilla.
Oh, yes. I got 2 new Godzillas. I got the one back over there, and I got this one up here.
It's just a big and small.
Yeah.
They both roar.
Both roar,
Same
they both
thing, just
light up.
two sides.
They both scared the heck out of Norman, so it works. Let's see here. Okay, we're going to be wrapping it up in just a few minutes, so I'll take a couple more of your questions, and then we will end it for tonight. And an added bonus, you can do the weather forecast for the games as well. That is true. For one, okay, if I'm the head of baseball operations for the Mets, one thing I can guarantee is that we will not have long rain delays. Because I'll be able to look at the radar and say, nope, we're done. Now, the thing that complicates things is that Major League Baseball controls it once the game is actually started, so you can't really do anything about it. So I'll make the call before the games, and I'll get good players. So I'll make a rule. No one over the age of 35 should be coming in as a free agent. Nope. And no Aaron Rodgers for the Chiefs game this weekend. That's true because of COVID, which I find ironic. Hopefully my Chiefs could start playing better because, my God, been giving me a heart attack. But see, years of being a Mets fan has taught me not to overreact during these difficult times. And as a result, I'm kind of even keel. But you see, the Chiefs winning is what keeps me sane during the summer when my Mets keep on losing. So, not cool.
What keeps me sane?
Well, the Care Bears movie.
No.
No?
No, that's just me.
No. I think see, my wife does not like watching sports with me, but I think that if you just give it a chance and we just go back, we should start off first with watching the 1960 season of football.
No.
And work our way up. And I think you'll gain more of appreciation for the game.
No. Listen, I put the games on for you, okay?
Okay.
I just do my own thing.
Yeah.
No problem.
No, I want you to watch with me.
No.
We'll do cheers.
No. No, I'm definitely not the cheerleader type.
I think I'm going to get something thrown at me if I keep this up. Okay, so we are coming up on 9 o'clock, and that means I'm going to be sleeping soon. If anyone else has any other questions? Yeah, that's true. If anyone else has any other questions, get them in the next 2 minutes. Otherwise, we will shut it down and get ready for another fun day of forecasting for tomorrow at 3 a.m.
I want to chime in a second. I don't want anybody to get the wrong idea because I will put the football games on.
Yes.
Or baseball, whatever season it is.
Yes.
I will have it on and ready for you when you come in the door from work.
That's true. That is true. The thing is that I would like you to watch them with me, and then I could explain the whole game to you. But, then again, I kind of go off on a rant too when it comes to baseball. I hate the shift. Yeah, well, that's true. I hate the shift. I really wish they'd do away with that nonsense. So I just want to fall back on one other thing, and that is the stratospheric warming we're seeing here at 10 millibars, which is causing a disruption in the polar vortex right now. Notice this cooling area. This is a sign that we should see the polar vortex strengthen, thus the milder weather pattern that's going to be on the way. What's going to be very interesting is when this cooling gives way and we see another shot of warming like what we're seeing here, how much of a direct connection between what we're seeing here in the tropics starts to play into this transport. So I would say by about, let's say December 1st, what I want to see is whether or not this extension starts to reach down towards the tropics. And where you want to look for your strongest warming is over here in Asia. Okay? So if you see this type of blob here taking place in Asia and then working its way up towards the higher latitudes, that's a strong signal for a major disruption. And that, ladies and gentlemen, will be game on for an active winter weather pattern. So I think I'm going to close off on that. Let's see here. Card tells me what I need are hitters. What I need is someone to teach them how to play baseball, basically. But anyway, that's it for tonight. We have gone up to the 9 o'clock hour. I want to thank everyone for joining. Again, if you're interested in the merchandise, here it is right on the landing page. So if you want to pick up a sweatshirt, t-shirt, mug, whatever, it'd be greatly appreciated. It'd be really cool. And that is it for tonight. So have a wonderful evening. And as always, stay safe out there.